We are now going to cover section 1.5, the last section of unit 1 for our statistics OER course. It is on experimental design and on ethics in statistics. In terms of OpenStack's Intro to Statistics book, this is section 1.4, experimental design and ethics. And in terms of the Lumen Introduction to Statistics with Corequisite course, this will be the links in module 1 for Introduction to Experimental Design and Ethics, and then the components of the experimental design and ethics in statistics. This video will focus on experimental design. There are different kinds of studies in statistics. In prospective studies, individuals are followed over time and data about them is collected as their characteristics or circumstances change. Birth cohort studies are a good example. For example, let's say after a nuclear accident, to follow the people who were born very close to it or during a period of time after the accident, and see how maybe the accident influenced their genetics. Other things would be if you have an immigrant cohort coming, let's say, into the States from a particular situation, and then following that cohort to see what happened and how their life improved or not improved, or what happened to them. This would be a prospective study. A retrospective study would be when individuals are sampled and information is collected about their past. When I asked you, how many hours did you sleep last night? I can also, for example, if I want to identify whether somebody can be diagnosed with a specific neurodivergent condition, I can ask questions about their past, like how old were they when they started demonstrating certain characteristics? When did they speak for the first time? When did they walk? How old were they when they rode a bicycle? Things like that will be a retrospective study. In an observational study, characteristics of the individuals are simply observed and recorded. Of course, this could be a prospective study or a retrospective study, where we are just looking at what's happening and we are collecting the data. In cross-sectional studies, data is collected from many different individuals at a certain point in time. There is one particular type of study, however, which is called an experiment. And the purpose of an experiment is to actually investigate cause and effect situations, a relationship between two variables. And having a relationship between two variables that are isolated is extremely difficult. And that is because things that happen usually have influences from more than one variable. When one variable causes change in another variable, we call the first variable the explanatory variable and the second variable the response variable. And in a randomized experiment, the researcher manipulates the explanatory variable and measures the resulting changes in the response variable. But for the experiment to be well designed, the other variables that could potentially influence the outcome, the response variable, must be kind of kept either constant or be randomized in a way that they will not influence the outcome. The different values of the explanatory variable are called treatments, and an experimental unit or observational unit is the one single object or individual to be measured. So one unit of the population that is actually participating in the survey. So let's say that we want to investigate the effectiveness of vitamin E in preventing disease. So we recruit a group of subjects and ask them if they regularly take vitamin E, and we notice that those who said yes also exhibit better health on average than those who said that they don't use vitamin E. Does this prove to you that vitamin E is the cause that can guarantee effective disease prevention? So that's the question. So think about it, pause the video, think about it, and determine if, by asking this question, this is an observational study, you recruit subjects, you ask them if they take vitamin E, you record yes or no, and then you check their health. So this is not an experiment. Does this observational study guarantee that vitamin E is effective in disease prevention? So the answer is that this is not true. People who take vitamin E are also very likely to exercise or to follow specific diet, be aware of better nutrition practices, take vitamins, maybe not smoke. These are contributing variables in good health, and you also need to check those variables if they are present and if those influence the health of the subjects. Another item that might influence the health of a subject is the location where they live. If someone lives very close to a factory or to some source of radioactivity, pollution, we don't know what may affect somebody's health, and these variables were not taken into account. Additional variables that can cloud a study are called lurking variables or confounding variables. In order to prove that the explanatory variable is causing a change in the response variable, we must isolate the explanatory variable. The researcher must design her experiment in such a way that there is only one difference between the groups being compared, and these are the planned treatments. Now, how is it possible to secure that only one of the variables is changing? This is accomplished by the random assignment of experimental units to treatment groups. When subjects are assigned treatments randomly, all of the potential lurking variables are spread equally among the groups. At this point, the only difference between the groups is the one imposed by the researcher. Different outcomes measured in the response variable, therefore, must be a direct result of the different treatments. In this way, an experiment can prove a cause and effect connection. So, in an experiment, we do manipulate some of the variables. In an observational study, we do not manipulate any variables. We are just recording data by observation. When participation in a study prompts a physical response from a participant, it is difficult to isolate the effects of the explanatory variable, and to counter the power of suggestion, researchers set aside one treatment group as the control group. The control group gets a treatment called placebo, which is a treatment that actually cannot influence the response variable. The control group helps researchers balance the effects of being in an experiment with the effects of the active treatments. Of course, if you are participating in a study and you know that you are receiving a pill which contains no actual medication, then the power of suggestion is no longer a factor. So what do we do in order to avoid situations where the participants of a study will assume or be aware of the fact that they are not receiving a treatment? So this is called blinding. Blinding is the situation where in a randomized experiment, the person involved does not know who is receiving the treatment and who is receiving the placebo. So we all participate in the study. We all think that we are receiving a treatment, maybe a new method of teaching, maybe a new drug may be a new weight loss supplement, but some of us are not receiving it, and we don't know if we are in the group that gets the placebo, no treatment, or if we're in the group that gets the new treatment. Now, a double-blinded experiment is when the person administering the actual survey also doesn't know. So the researcher that will provide you with the treatment, the doctor or the person at the fitness club or at the nutrition center, the person administering you the pill or the treatment doesn't know if that is the new treatment or not, or if it is a placebo. So in the cases of drug administration, then the drugs look identical to each other. And the person who provides the researcher or the doctor or the professional who's administering the drug with the drug knows where the drug came from. That's a double-blinded experiment. So let's try to go back into key terminology and in the sense of experiments here. We have an example. Researchers want to investigate whether taking aspirin regularly reduces the risk of heart attack. Now, this is a cause and effect question. Are you taking aspirin? And if you take aspirin, will the risk of heart attack be reduced? 400 men between the ages 50 and 84 are recruited as participants. The men are divided randomly into two groups. One group will take aspirin and the other group will take a placebo. Each man takes one pill each day for 3 years, but he does not know whether he's taken aspirin or the placebo. At the end of the study, researchers count the number of men in each group who have had heart attacks. Identify the following values for this study. So your job is to understand what is the population, what is the sample, who are the experimental units, what is the explanatory variable, what is the response variable, and what are the treatments. Treatments are the changes in the explanatory variable. So pause this video, try to fill out these areas, and then resume the video to check the answers. And the population are men ages 50 to 84. The sample is the 400 men ages 50 to 84. The experimental units are each of those 400 men who were selected to be in the sample. The explanatory variable was an oral medication given to these men. The response variable is whether they had a heart attack or not. And the treatments were aspirin or placebo.